Welcome to all of you. Welcome to this session where we shall go further in the study of chemistry, where in the first chapter we happen to see what is all the chemical aspects that are present around us. But now we will be going specifically to the compounds that we are having in these chemical studies. And that's what happens to be the name of the chapter: acids, bases and salts. Have you come across these words anywhere? Definitely the word salt you must have come across, because whenever we are having food, it's that salt which gives a little change in taste. A little bit missing of a salt, you feel it is pretty much a bad taste. If it is a little more, you are not comfortable to eat it. So that is how we have heard this salt in day-to-day basis. What about acid bases? I am sure you would have come across this in general terms though, but now we will talk more with respect to chemical aspects. So what is all the study about acids? Some diagrammatic views here that we have, where in one place you are able to see a sort of vapor that is going up. Now please be aware that there is no heat supplied here. You have not supplied any heat or anything, still you see some vapor. So keep this observation in your mind. When we are studying further aspects of this, we will be referring to this figure once we go there. Here you can see some heat, there is some burning happening inside, there is some churning of sorts happening inside, and definitely when there is burning there has to be some amount of heat. You have a couple of salts here, seems more like the white salt that we have for food. This seems a little colored one. What is all this about? These things we do come across in our regular aspects, but when we study its properties, we can give certain chemical aspects to those compounds. So having seen certain general parts, what we will now see is that these aspects of acids, bases and salts are those compounds which have different properties. Bitter, sour, these two words you must have definitely heard about in various parts. So when do you use these components? That let us see. So in this segment, in this part, we will study mainly about acids. So first thing, what is an acid? Now this word acid happens to be derived from a word called as acidus, where the meaning of that word acidus indicates sour. The bitter part is being associated with those compounds which are bases. So what is this acidus is nothing but those compounds which are sour in taste. But everything you cannot base on that one physical property. So when you talk about chemistry, then you start talking about hydrogen, helium, all the small elements that you have come across, carbon for that example. So what is an acid? They happen to generalize it as those compounds which can give H plus ions, hydrogen ions. Now some basics regarding this: when you see the periodic table, hydrogen is denoted as H. It is the first element that is denoted in the periodic table, where atomic number and mass number, these aspects you do study in your further chapters or further classes, where atomic number is nothing but the proton that is present in the system. Generally we have something called as nucleus in an atom, which is a centralized part, and this nucleus will contain a proton, and then there is an electron which is present in the outermost part. So those compounds which are able to give this hydrogen ions, now what does plus indicate is the one electron that is present in this hydrogen is removed out. If hydrogen is this, H plus indicates that there is a proton inside but no electrons are available. So this is how we segregate this component of acid are those compounds which can give out H plus ions in these cases. Moving further, they also happen to classify these acids as those compounds where the ions can be split apart. What is splitting? Dividing them into various parts. Now when you see this definition parts, there is not much clarity in this. But when we try to take certain compounds and study, that is when the clarity aspect about this acid compounds come. So first up, let us see the physical aspects itself. So what are the physical aspects here? Nice guy there. You take that lemon and taste it. What is your very first reaction? Are you happy tasting that or are you sad? Now that seems to be a pretty much mixed feeling that you see. So that lemon is giving such a type of taste where you are not able to express whether it's a nice one or a pretty bad one. Now those are nothing but which we term it here as sour in taste. That lemon which is eating is sour in taste. Which acid is present? Let's see at a later stage. These are sour in taste, generally all the acids. Organic acids, they are weak and harmless. There are some acids which are very strong. For example, we have an acid called as sulfuric acid, which is H2SO4. Now supposedly if this acid falls on your hand, which probably if you continue in the science stream into PUC, you will be doing many experiments regarding this. And supposing if this H2SO4 falls on your hand by mistake, you will immediately see a black mark there. And that area around that acid where it has fallen will be burning for you. So that is because it's a very strong acid, it reacts very strongly. But organic acids, what are these organic acids? One of them, the best possible example that you can know is acetic acid, which is commonly called as vinegar. Now if you have some interest in cooking and if you always do enter into the kitchen and you observe your mother cooking, this vinegar is one important component that has been used in various cooking purposes. So these type of acids are used because they are weak and harmless. Now for that same cooking you can't use this H2SO4. But organic acids, because they are weak, they can be used. We have another aspect here where acids turn blue litmus paper into red. A small brief recap of what is this litmus paper. So suppose we take a solution. We have certain papers where litmus, this was also obtained from a tree, and what this litmus paper does is, it is an indicator. Now what's an indicator? The best way to understand this is, suppose if you are going on a road, you have so many signals available. What are those signals? They are indicators. You have a green light, it essentially means that you can move forward. What does a red light mean? It means that it indicates that you have to stop. Now this indicator, supposing we take a blue litmus paper and if it turns into red, those compounds we can call them as acids. What if this blue indicator retains itself? Then it is a base compound that is present. So this is how the properties of the compounds can be shown. We also have certain other aspects, physical aspects, where if you use a methyl orange, this is nothing but a solution. This methyl orange will get converted into red color if acids are present. Phenolphthalein, originally phenolphthalein is colorless, but that shows a differentiation between acids and bases. These are all practical aspects where you will be observing this once you get inside a practical chemistry lab, where phenolphthalein is colorless. The colorless nature retains, but if base is added, which you will be studying in the second part when we deal about bases. So when base is added, it turns into the color of phenolphthalein, which is pink. But in the case of acid, it tends to continue to remain colorless. And these acids, definitely you can dilute it. This is nothing but, suppose you have a sugar solution where, you take a beaker and say you have taken so much of water and also there is presence of sugar molecules. Now once you take a sugar molecule, it might taste sweet, but then you add furthermore water and maybe this level shall be increased to this. Please understand, don't add any more sugar but add water. What we are doing there is, we are diluting the solution. Please try this practically. You will feel that the sweetness of the solution has reduced. That is what we call it as dilution, where you can dilute various acids which have been present. So these are certain physical aspects of acids that we tend to see, and as I told you, let us see some common acids which are being present here. We have citric acid, citrus fruits, example orange. All these fruits, if you see, they are all having a pulpy layer of sorts. It is mainly these type of acids which are being present in that. Then is it harmful to our body? Definitely not. We have acids which are strong, naturally they are harmful, but these acids are the one which actually help our body to work in a proper way. That is why you are being advised to eat fruits and vegetables regularly. It's also used as a preservative. You can see that whenever foods are being oxidized, or in the simple sense you can call that, when you keep food for a long time, maybe they get decomposed of sorts. So that can be controlled by using the citric acid in those cases. Lactic acid found in yogurt. Yogurt is a type of food which is actually mixed with curd items and all. So we find that acetic acid, vinegar, I happen to tell you about this, mainly utilized in the food industry or say in general kitchens also. Carbonic acid, phosphoric acid. Some formulas are given for you for just understanding what these compounds chemically mean. Now this carbonic acid is used in soft drinks, Pepsi, Coca-Cola, anything. So you see that the moment you open the stopper that is present, there is a sudden gush of gas that comes out. Now that gas is carbonic acid. Once again, naturally it has to be a weak acid, because if it's a strong acid you are not going to sustain. But this carbonic acid is not as weak as the other ones, and that is why you are being told not to drink more of these type of soft drinks, because the carbonic acid that is present in the soft drinks which are present, over a period of time, it may not affect you immediately. Over a period of time, it is going to affect your digestive system and respiratory system. The last one, hydrochloric acid. Now the question is hydrochloric acid strong or weak? Hydrochloric acid is a strong acid, but our stomach actually produces hydrochloric acid in small quantities, in less concentration. I hope you understand the word concentration. Concentration means the quantity of the substance per volume. So in our stomach there is a minimum amount of HCl created, and that is a must. If that HCl is not created, then the digestion in our body will not happen. So please be aware that a minimum amount of hydrochloric acid is already produced in your body. If you add more acids in our body, say like carbonic acid through soft drinks, it is going to affect us. So these are certain important common acids that we probably find around us consciously or unconsciously. Some of these acids where I happen to tell you, say like hydrochloric acid, we are not aware of it, but daily there is a production of hydrochloric acid in our stomach. So moving further from these parts, now we got to segregate these, which are the strong acids, which are the weak acids. Now how do I call this as a strong acid? That is where the study of science becomes practical. No doubt we study so much of theory associated with this, but all the aspect of strong acid, this can only be understood where in the laboratory we see that whenever we undertake reactions with these acids, they are pretty much strong. You can see sulfuric acid, the way it is giving out vapors there. So those vapors indicate that they are very strong acid. Immediately on pouring the sulfuric acid in the beaker, which may be having a little amount of water or say even moisture, it will react and give those vapors. But then the question is, how do we determine it theoretically now? For this we have a concept of dissociation. Dissociate. Associate means get together. Association, get together. Dissociation means split. So say an acid like HCl, this will undergo complete dissociation, which means that if I have used HCl, I will be forming H plus and Cl minus. The first part that we write is the positive part, the second part that we write is the negative part. So what does a strong acid mean is that those acids which can undergo complete dissociation. This is an example, say for hydrochloric acid. Let me also give how the dissociation happens for sulfuric acid. Now please understand that in sulfuric acid it is H2SO4. So when this is H2SO4, it means that there are two hydrogens present here. And we are already aware about writing the formula. So if that is the first aspect that I have to just explain you, hydrogen is +1, SO4 is -2. And this is how, if you remember in your 7th and 8th classes, we have understood writing the formulas where cross multiplication will give you H2SO4. Now since this SO4 is just 1, we need not again specify it. So this H2SO4, if I have to undertake splitting, it will be H2SO4 giving rise to, since there are two hydrogen atoms, I will be taking it up as 2H+, which indicates that two hydrogen ions are formed. And what is the other thing now? The other thing is SO4 2-. SO4 is the one which is present that has a negative charge of 2-. So what we can understand by this is, in sulfuric acid, per molecule of sulfuric acid, you are getting 2H+ ions. And do you remember the very first statement that we studied about acid? What is an acid? We studied that we obtained it from Latin name acidus. What was the chemical aspect that we studied? Acids are those compounds which release H+ ions. So whoever releases H+ ions, we term them as acids. Now the same thing, if I use a comparative study with respect to HCl, I can see that H+ and Cl-. So two examples, HCl splitting, H2SO4 splitting. You can understand here that per molecule of HCl, you will get 1H+. Whereas per molecule of H2SO4, you will be getting 2H+ ions which are present. So this is how the splittings are done. In the same way, I hope you will be able to analyze this H3PO4. Maybe you can just try these aspects, but slowly I will be explaining. I hope you will also be trying this H3PO4. Now I understand very well that there are 3 hydrogen atoms. So naturally I should be getting it as 3H+. And what is the other part? This is phosphate part, phosphoric acid, phosphate part, PO4. This has to have 3- because that is how this H3 will be formed. Once again, to just explain the basics, we know that H is having a +1 charge, PO4, if it has a -3 charge, this is how we can write the formula H3PO4. And we understand that per molecule of phosphoric acid, you get 3 hydrogen ions. I think with so much of a study, the last one should be easy for you, the nitric acid, which is HNO3. Once again, since the name itself says that it is an acid, naturally it should form H+ ion, and then we should be having a production of NO3- ion. This is the nitric acid that we have, and be clear that strong acids indicate that there is a complete dissociation of the molecule, of all these molecules in fact. But if this is the strong acid study, then what about the weak acid study then? So weak acids obviously should mean that there is no complete dissociation. Naturally there will be some dissociation, but not complete. So let me take, say, one example for this, say acetic acid, where the formula is CH3COOH. This is the acetic acid. Because I am discussing with respect to dissociation, let me complete that and then get to all these examples that are shown. So acetic acid, the dissociation, we know very well that if it is an acid, definitely it should give out H+. That is the very first aspect. Then the other aspect is it should give you CH3COO-. So one aspect is CH3COO-, the other aspect is H+. But when we write the arrow mark, we are not going to write just this, we are going to show it like this. Now what does it mean? One arrow is showing that way, one arrow is showing in the reverse way. This we can tell that it is a reversible reaction, which means that when I dissociate this, H+ is formed, no doubt, but they are not completely dissociated. CH3COO- and H+ may again combine back to form acetic acid. So this is how we can understand about the strong acid and weak acid. We have some more examples here: citric acid, tartaric acid, ascorbic acid, carbonic acid. What you can understand by these is that those acids which we use in foods are generally weak acids. We have some pictorial representations here. Lemon, we have soft drinks for carbonic acid, juice where citric acid and all is present, and tartaric acid, we can find it. So what we understand by this is foods generally contain weaker acids, whereas stronger acids are mainly meant for various general reactions that we tend to take place. So moving further from this part, now this is more of a chemical aspect, that is what I was talking about, the factor of dissociation. What do you mean by dissociation? Cutting across. Association getting closer, dissociation cutting across. That is what in terms of English language, in words for you to understand, it has been put up here. So strength of an acid, I have already told you what is a strong acid, what is a weak acid. If it undergoes complete dissociation, it's a strong acid. If it does not undergo complete, if it undergoes partial indicates some amount is dissociated, some is not. So you can see that the strength of an acid depends on dissociation of H plus ions, which essentially means that more the H plus ion, more stronger is the acid. Lesser the H plus ion, less stronger will be the acid. So this is one part. Strong acids undergo complete dissociation, weak acids undergo partial dissociation. Partial indicates minimum. Now this is hydrochloric acid, sulfuric acid. This is called as methanoic acid. The study of organic compounds will be coming across in the 4th chapter, where we deal about the organic compound studies. So more detailed study about this we will be doing there, but what we need to understand here is that if this is a weak acid undergoing partial dissociation, how am I going to write these aspects? So suppose if I take CH3COOH, I am going to basically write a reversible arrow mark which indicates that there is no complete dissociation, and naturally I must be getting H plus. If I don't get H plus, then I cannot classify it under acids. And what is the other part that I have? CH3COO minus. One is the negative part, other one is the positive part. So this is called as ethanoic acid, 2 carbon system. This is called as propanoic acid. As explained, the study of this with greater detail will be at a later stage. So this is about the strength of an acid, how strong is an acid, how weak is an acid. So having seen these parts, now one thing is quite clear, that naturally the strong acids which are there, they would love to undertake various reactions. What do you mean by being strong? They cannot be stable, they cannot be silent. That is how we are in general. When our energy is very high, do we prefer to sit at a place? Definitely not. But yeah, when tired, we are happy to be at a particular place. A complete dissociation indicates that the strength of an acid is very strong, and more strength indicates more work that it takes place. So what we realize here is that these acids can actually go and react with other compounds. Now, you can't have a reaction between an acid and an acid. We have studied very well that, especially say in the study of physics, you must have come across where like charges, unlike charges. What are the properties in this cases? Basically, a like charge indicates that if there are 2 positive charges, will they attract, will they repel? If there are unlike charges, one positive and one negative, will they attract, will they repel? Think over a little. If you have a little confusion over this, you would realize that these are those components which don't attract each other. So generally it is the unlike charges which attract each other. So an acid would love to react with the other type of compound, where an opposite property which shows for acids are bases, which we will be studying in the second part. But these acids would love to react with various metals which have been present and other compounds. So what are those reactions that let us just go through, which we terminate under chemical properties of acids? So what do we mean by chemical properties is reactions that take place for these type of compounds. So we have one reaction where on reaction with metals, we see that we always get the formation of salts, and along with this we get hydrogen gas. The reason for this is a metal is generally basic in nature. Metal components, they generally tend to be basic in nature, and these metals whenever we have an acid, which you are quite sure now that an acid should have H plus ion. So this H plus ion will get culminated into hydrogen gas. Always remember that whenever we tend to write reactions, we definitely look to balance those parts which are there. So the reaction which I have given here, if you observe this entire reaction, it is not balanced. So this aspect is very important, and this is what you happen to study in the very first chapter about balancing of reaction. So how will you balance this reaction now? Here in this case, hydrochloric acid is an acid with a metal. Then you have a salt which is nothing but sodium chloride NaCl. It is, in general sense, we call it as table salt. So this NaCl which has been present here is obtained from sodium metal and the chlorine of hydrochloric acid. So how do we balance these aspects now? Hydrogen is written as H2 because we know that gases cannot be monoatomic. This we call it as diatomic because two atoms are combined. Because gas molecules in 9th standard, if you have studied, gas molecules are not held tightly. It is the solid molecules which are held tightly. So gas molecules would like to spread along in the given area that is present. So to hold them into a stable form, we have it as H2. So the first thing that you have to balance is the hydrogen, therefore I have to take it as 2HCl. 2HCl indicates that this part which has been present here, it balances the hydrogen. Now the moment I balance hydrogen, the problem comes with Cl, because this side there are now two Cl atoms, here it is only one Cl atom, and therefore this becomes 2NaCl. Now always remember that this is what we call it as atomic form. Writing it beside, we call it as molecular form. And for balancing reactions, we always use the molecule form. Is this balanced now? Definitely not, because you can see that no doubt the two chlorine atoms got balanced, but unfortunately there was a disturbance with sodium, and therefore we tend to write this as 2Na. Please remember that for balancing of chemical reactions, there is no hard and fast rule. It is only the trial and error method where we have to see on either sides that has been balanced in the case. Now this hydrogen which is there, it is in the form of gas, so it gets liberated out, and naturally whenever gases are produced, these come under exothermic reactions. What are exothermic reactions? Those reactions which will give out energy. The opposite of that is endothermic, which will actually take energy. Now here this is exothermic because the gas is going out, and this is one interesting study that you have studied about the hydrogen gas, where if you bring it near the burning splinter, you will actually observe a puff sound which has been present. So this is one type of a reaction that we tend to see with this metal cases which have been present. After metals, we also have reactions with carbonates and bicarbonates. What are carbonates? What are bicarbonates? Carbonates are those compounds where we generally have it as CO3. Carbon, carbo, carb and O. That is nothing but the oxygen part. So the terminology given to that is carbonate. And this carbonate, please remember that it tends to have -2 charge. Whereas bicarbonate are those compounds, bi basically indicates the hydrogen carbonate, HCO3, and the charge associated with HCO3 is minus, because here it was 2 minus. When hydrogen came, hydrogen brought 1 plus charge. So for this 2 minus, 1 plus charge was introduced in terms of hydrogen, therefore this becomes a negative charge. So now what we see here is that acids will react with carbonates. As usual, they form a salt. If you remember in the earlier reaction, acid reacted with metal and formed salt, and even now what you are doing is acid is reacting with the carbonate, it is forming the salt, but the byproducts are changing. What do you mean by a byproduct? Product is the main one. Now here the main thing that I want to obtain is the salt, that is NaCl. All others, they are not needed for me, but then when you do the reaction, naturally you get water also, you get carbon dioxide also. So we term all those as byproducts, which essentially means that we obtain them, but we are not interested in having them for any use. Our interest is mainly in this NaCl. Now what we see in all these things is that acids will react with carbonate to give salt, water and carbon dioxide. One thing that you can see is that these are reaction for acids with carbonate, this is with acid with bicarbonate, both of them are given with an example. You can see that the products are exactly the same. It is the same NaCl, sodium chloride, water, carbon dioxide. So what is the difference here? It is just that there was an additional hydrogen, there was a difference in the sodium atom. So all the difference that has come is in the balancing of the chemical reaction. This reaction which I have shown here is a balanced chemical reaction where hydrochloric acid with carbonate will give you salt, water, carbon dioxide. Similarly, hydrochloric acid with bicarbonate shall give the same products. What differs is only the balancing which has been present. While for hydrogen we had the test where you could have passed the hydrogen gas and you would get a pop sound. For carbon dioxide, where you get it in both the reactions, the test that is used is if you pass it through a lime water. What is lime water? Is lime, when you use it, make it into sort of a solution. If you pass it, it becomes milky. Milky essentially means you will not get it bright white as such. Like the way the milk gives a layer of whitish color when, say, suppose you dilute it with water, same way you will be able to find this. Now that is because carbon dioxide gas will react with the lime which is present. The reaction aspect you will not be studying now, but what we are seeing here is the practical aspect where carbon dioxide gas, if passed in lime water, will be making it into milky color. So this is the second set of reactions we happen to see with respect to the properties of acids. The first were reaction with metals. This we saw hydrogen gas was observed. In the second set were carbonates and bicarbonates. Also just remember that carbonate is CO3 with a 2- charge, whereas bicarbonate is HCO3 with a 1- charge. Both of them have given salt, water and carbon dioxide. So moving further, after these two set of reactions, we have reaction with the metal oxide. The word itself says it. What is the metal oxide? There is a metal present, zinc, and there is an oxygen present. So these type of compounds, metal oxides, can also react with the acid and the process remains almost the same, where the metallic part, that is zinc, is reacting with the negative part of the acid. Now what is the negative part of the acid? See, when I split this HCl, naturally I will be getting it as H plus and Cl minus. So in this case, since this is the positive part, zinc is the positive part, it reacts with the negative. Again back to the theory of unlike charges attracting each other, the same thing. The positive zinc part reacts with negative part. And what is this formula then? The formula is basically, if you see from this compound, we can understand that zinc is +2 because oxygen is -2. How do we know this? You see in the periodic table, oxygen has atomic number 8. And after atomic number 8 oxygen, you have fluorine and then you have neon. What is this neon? It is a noble gas, which is a stable gas. And everybody would like to get the configuration of a noble gas. So for this oxygen, if it has to get like neon, it needs 2 more electrons. Therefore, the charge on oxygen will be 2-. Suppose you consider for fluorine, it will be 1-. For neon, it will be 0 because that itself is in stable form. So what we understand by this is, zinc is having +2 charge, Cl is having -1 charge, and therefore that compound has been formed. So this is how various type of reactions can be formed. Let me just give you another example where, say, suppose if I consider aluminium oxide, Al2O3. So what is this Al2O3? If I react it with HCl, naturally, you have got this formula because aluminium is having +3 state, oxygen is having -2, and this is how you have crossed it. Aluminium with +3, oxygen with -2, and therefore you have got Al2O3. React that with HCl. So what is the product? One product is quite definite, that you must be getting AlCl3. Now why you should get AlCl3 there? Because once again, Al is +3, Cl is -1, you have to cross this and therefore you get AlCl3. And what's the byproduct? Same water, because the nature of the reaction is same, so naturally water will be the byproduct. Only thing is now you have to concentrate on balancing, understanding the first chapter which was taught to you earlier. So what is the balancing that we can do here now? Little tricky because lot more atoms are there. How many atoms are here? 2 aluminum atoms. So therefore I can write it as 2AlCl3. This is one thing that I can settle. 3 oxygens are there, so there is only one oxygen, so let me write it as 3H2O. Hope this is clear. There are 2 aluminum atoms here, so therefore I have written it as 2Al, so aluminum is cleared. Oxygen, there were 3 oxygens here in the H2O there was only one oxygen, so I have written it again as 3. Now what I see is that chlorine is 3 into 2, which is 6. Also hydrogen is 3 into 2, which is 6. So if I just put it as 6HCl, I can write it as a balanced chemical reaction. So if I have to write this as a balanced chemical reaction, I can write it as Al2O3 plus HCl giving rise to AlCl3 plus H2O. So as explained to you, just look at balancing the aluminium, which is 2, oxygen, which is 3, and then we see that 6 chlorines and 6 hydrogens are there, and therefore make this as 6HCl. Metal oxides react with acid to give salt as well as water. So this is the parts that we see with respect to various reactions associated with these compounds, where we saw with respect to metal in the first place, then carbonates and bicarbonates, which naturally have metal in them, and then oxides, which is nothing but metal oxide reactions with acids. So having seen all these acid reactions with various types of compounds, let us just tabulate some of the naturally occurring acids that we tend to see. We happen to see this actually at the start of the chapter also. So now what we are doing is just going through these aspects, where citric acid, you find it in oranges and lemon. Malic acid, at this stage you will not be dealing with the structure of these compounds. At the lower stage we are only concerned of what are the practical usage that we do. No doubt in moving forward we will be looking at the structures of these compounds also, where you see tartaric acid in tamarind and grapes. Especially if you eat tamarind, you will see that it is pretty much sour in taste. But yeah, many people do love to eat that tamarind. So the acid that is present in that is tartaric acid. Acetic acid in vinegar, oxalic acid, tomato, spinach, lactic acid, sour milk and yogurt. And then you have ascorbic acids, mainly in fruits and various vegetables that we have. Tannic acid, tea. Tea is actually grown in slope gardens. If you see this tea production which is there, it is normally in places like Assam or say Cochin, Kunnur in the South India, where the growth of this depends on the temperature of the places which have been present, and that aspect of tea where we actually get a smell of tea smell that we say when you heat it, when you boil it, that is because this tannic acid which is there undergoes decomposition. So this presence of an acid is important in that. Hydrochloric acid, gastric juice, that was what conveyed to you that hydrochloric acid is produced in our body, especially in our stomach. So whenever we eat food, the hydrochloric acid that is present is able to take part in digestion and we will have a healthy state. So suppose there is less production of hydrochloric acid, we see that our body digestive system doesn't run perfectly. Then we have folic acid in the lettuce leaves, which is generally the large leaves that we find. Stearic acid in mustard oil, formic acid. Sting of ants, especially when you are bitten with a bee or an ant. The first thing that you see is, suppose you get bitten here, it gets bulged. Now what does that bulging mean? That we will see it at a later stage. In part 3 we will be discussing about that. But I am sure you have seen this phenomena, maybe with you or maybe with somebody else, that especially if an ant or a bee bites you, suddenly there is a sort of irritation and then sometimes there is bulging. What is that? That you please kindly think over it. We will be discussing that in detail in part 3. But then what you need to know here is that the sting of ant and bees will have formic acid present in them. So this is nothing but just a tabulation of various acids that we have across us in various sources, that is say in fruits, vegetables or various stings and all that we have discussed. So having seen all these naturally occurring acids as to their presence, we will just see the uses of various acids that we have. Sulfuric acid used in manufacture of fertilizers. Where do you use fertilizers? I think if you are farmers or if you have been living in the villages, fertilizers is something that you use for plowing and all, sowing the seeds, where you believe that on adding these fertilizers, better growth of plants and all can happen, or say crops. So ammonium sulfate, explosives. Nowadays you can see that whenever you want to bring down a building, so what they do is they use this dynamites and all, and then they explode it, or even say in terrorist activities they do use these parts. So this sulfuric acid which is there is one important aspect that we tend to use in various such compounds, paints, drugs. Nitric acid, it is used in the manufacturing of fertilizers. Once again you can see that some more uses repeat, but then the type of acids that are used will be similar, because what happens here is a fertilizer will not be containing just one compound. We have certain important fertilizers like NPK fertilizers we call, which is containing nitrogen, potassium and phosphorus. So along with this you will also have the presence of acids like sulfuric acid and nitric acid. You have hydrochloric acid for cleaning metals, tanning and in printing press. Benzoic acid is used in food preservatives. This we normally see in preservation of pickles and all, and also acetic acid for flavoring food in these cases. So this is how we see various uses of these acids which have been present. So having seen all these aspects, now let us take an assignment of sorts just to understand how much have we assimilated the concepts that were dealt here. Because what happens is the compounds here dealt happen to be of our day-to-day usage, and application of this compound seems to be very important for us to understand. So what is the first question here? Which gas is usually liberated when an acid metal reacts with a metal? This was the first type of reactions that we studied under acids. So you just got to revise as to what was the reaction between an acid and a metal. Illustrate with an example. Think over it. I have given one example here. Hopefully you can find out some other example by yourselves, but be clear that you have to write a perfectly balanced chemical reaction. How will you test for the presence of this gas? There was a small point which was being told to you when we were discussing that the gas which was eliminated there can be tested. Please go through that entire part. Compounds such as alcohol and glucose also contain hydrogen but are not categorized under acids. Now this aspect was not directly dealt with you in this video. I have not explained you directly, but I think you should be using a little bit of your thinking as to why these compounds are not probably under acids. Let me just give you the structure if you want for this, where say for example an alcohol, you can take an example of C2H5OH. Now we have happened to say that acids are those compounds which give acid H+. I can see 6 hydrogen atoms here. There is one hydrogen present away also. Even the glucose formula is C6H12O6. This is the glucose formula. So though it contains 12 hydrogen atoms, the question says that compounds such as alcohols and glucose contain hydrogen but are not categorized under acids. Please think over this. The answer for this shall be dealt in the next segment, but it would be nice if you can bring out the answers by yourselves. Last set of questions that we have give reason for the following. It is not advisable to preserve pickles in metal containers. Now for this, the first thing that you have to do is get into your house kitchen and see where the pickle is being preserved. And then you try to answer this, why it is not preserved in metal containers. The second one, vinegar is considered to be a weak acid. Vinegar is nothing but an acetic acid. So why it is a weak acid? It's already been explained. You have to properly put it in words, your answer. Aqueous solution of an acid conduct electricity. Once again, this is not dealt directly. For this, you have to combine a couple of concepts. First thing is, what is an acid? What does an acid give? And what is the requirement for electricity? Which type of compounds can actually help us in electricity production as such? So these are the aspects, assignment 1, and definitely we will be seeing the answers for this assignment in the coming section. So I hope you are clear with the concept of acids, various examples of acids and its various physicals and chemical properties. See you again. Thank you. Sai Ram.